they all have the electronic structure of neon. Clear?
Yes.
Any question? Okay. Now, let me ask you a simple question. Which one will be the biggest in size and which one will be the smallest in size? Okay, before you answer, think this way. From outside, they have the same structure, right? All of them, they have 2 core electrons. This is the nucleus. And you have 2 core electrons. And how many valence electrons for all of them?
8.
8. There are 2 core and 8 valence. 1, 2, 3, 4, 5, 6, 7, and 8. That's the shape for all of them. But there are different elements and ions, right? Which one will be the smallest in size?
The one with more protons.
Excellent answer. This means which one of these 4 is the smallest in size?
Mg.
Mg2 plus, not Mg, Mg2 plus, because they have the same electronic structure. And what will be the next one?
Na plus.
Na plus.
Na plus. And then what's the next one?
Ne.
Ne.
Ne. And then the next one?
F negative.
What?
F negative.
F negative. Can you bring one less than F negative?
Oxygen.
O minus.
Minus.
Or what?
-2.
أحسنتم. And less than oxygen.
Nitrogen.
minus 3.
أحسنتم. طيب, smaller than Mg.
Bigger.
Aluminum.
Na.
What?
Aluminum plus 3.
3 plus.
Excellent. So, can you tell now what's the meaning of isoelectronic?
They have the same electronic structure.
And you can tell what's the size of these elements easily by looking at their structures. Clear?
Yes, clear.
Very good, very good, very good.
Doctor,
Yes, what?
I didn't understand about how you can say from which one of these is smaller.
Okay, which one is, write the electronic structure of N3 minus. The one who asked in particular and everybody. Write the electronic structure of N minus, N3 minus. First,
Okay.
before we do this, write the electronic structure of nitrogen. What's the electronic structure of nitrogen?
It's 1s2.
1s2, 2s2, 2p.
6.
No,
Yes.
nitrogen.
3.
Yes. What's the electronic structure of N3 minus?
1 is 2, 2 is 2. 2p6.
Right. So the electronic structure of N3 minus. Now let me ask very simple question. Which one is bigger, N or N3 minus?
N3 minus.
N3 minus, much bigger. N3 minus, much bigger. We have more electrons outside with the same power inside. N3 minus is similar to which element?
Neon.
Neon.
Neon, exactly. Neon. All right. How about nitrogen? If I want to make it short, how should I write it?
Na.
No, I shouldn't. The one before it, which is helium.
He5.
2s2, 2p3. Is this clear? Good. What's the electronic structure for Ba2 plus in the short form? Quickly.
Zero.
HE.
HE.
No, I want the electronic structure.
XE.
No, S.
XE.
You have to look at the periodic table. The element which is before it, exactly. Okay.
6ST.
How about Be2 plus?
HE.
Neon.
Exactly. Helium. How about O2 minus?
NE.
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 I hope you get it. So we can do that. Very good. Now, when you put electron in element, okay. One thing. This is. We'll come back to this. Remind me to come back to this. But when you take electron from element, like for example, if you have sodium, it's 1s2, 2s2, 2p6, 3s1. When you make it in A plus, it will be 1s2, 2s2, 2p6. What will happen to the size?
Get smaller.
Get smaller,
Smaller.
decreasing.
Why?
Because there is one
One shell is gone, right? One shell is gone. So yes, it's smaller. Always the ion is smaller than the element. Okay. What will happen if you have? I want you to compare now. What's the structure of O2 minus?
Neon.
Neon.
What's the structure of F minus?
Neon.
What's the structure of neon?
Neon.
Neon.
So we have three elements, or two ions and one element. O2 minus, F minus, and Ne. Each one has how many electrons?
10.
10.
10.
But how many protons do you have for oxygen?
8.
And for fluorine?
9.
And for neon?
10.
So which one will be the smallest in size?
Oxygen.
Neon.
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 10 electrons are attracted to 8 protons. 10 electrons are attracted to 9 protons. 10 electrons are attracted to 10 protons. Which one will be attracted stronger?
Neon.
Neon.
10 to 10.
Neon.
And that's why this ion must be smaller than this one, must be smaller than this one. Clear? Like what we did with isoelectronic. Okay, this is now in this table. This is in here. The gray here is the size. The blue size of atom, and this is the gray is the size of the ion. So, see, when you make an A and A plus, look what happened to the size. This was the size of sodium. The blue thing is the size of the sodium atom. When you take electron from it, the size becomes very small, smaller like this. Always when you take electron from the atom, the size will be smaller. But when you add electron to the atom, here, this is the red is the size of nitrogen atom, N, and the gray is the size of the ion, size of ion.
Doctor,
Yes.
the attraction for the electrons, which one of them is greater?
The one with more protons. What do you mean? You're talking about
okay.
this?
Yeah.
The more protons, the more attraction.
Okay.
Okay, good. And this way you can tell which is which. Okay, good. Last thing, let's forget about neon. Let's talk about this element. All right, look at your periodic table. Look at your periodic table. And starting with, and forget about krypton. I want to talk about only, at this time, I want to talk about K plus, argon, P3 minus, S2 minus, Cl minus. Look at your periodic table and tell me what's the structure. Of course, argon is argon. What's the structure of K plus?
Argon.
What's the structure of P3 minus?
Argon.
How about S2 minus?
Argon.
Argon.
And Cl minus?
Argon.
Yeah.
Of these, which one is the biggest in size?
P minus 3.
P minus 3.
P minus 3 is bigger than what?
Then it's minus
S
2.
minus 2.
Bigger than what?
Cl minus 1.
Cl.
Then what?
Argon.
Potassium.
And then bigger than?
Potassium.
And then after that, let's go back now to neon. Where should I put neon? Bigger than argon or smaller than argon?
Smaller than argon.
Neon, look at the table. Smaller than argon, exactly.
Smallest.
All right, and then krypton.
Greater than argon.
And so we have all this arrangement. Is this clear? Okay.
Yes.
Last thing I want to talk about today, before we go, when you have transition metal, like Fe, what's the structure of Fe? It's argon, 4s2, 3d6. Clear? When you take the electrons to make the ion, you take it from S, not from D. So Fe2 plus, it becomes argon 3d6. Is this clear?
It's just for the transition methods.
But just for transition element, exactly.
Okay.
Exactly. All right. So if I, for example, if I say, let's have cobalt. What's cobalt? 27. What's the structure of cobalt? It's argon, and then
Argon.
4s2,
4s2.
2,
3.
3, 7.
7.
6.
Okay, what will be the structure for cobalt 2 plus?
Argon 3d7.
Argon, and then 3d7. We take the s electron out, not the.
If we had so we always take the electron from the orbital with the lower energy.
No, for transition metal only. Transition metal only. Transition metal. All right. For transition metal, when you take the electron, you take it from 4s. Or of course, if we go to iridium, which is under iron, I don't know what's the iridium. Do you have a table? I don't have a table with me. What's under iron?
Ru.
Iron. What's under Fe in the periodic table?
Ru.
Yes. Ruthenium, yes. Ruthenium, yeah, I forgot. Ruthenium. Ruthenium structure will be the noble gas, and then 5s2, 4d6. If I want ruthenium 2 plus, what will be the structure of the ruthenium 2 plus?
4d6.
Again, and then 4d6. no s electron. All right, with this I'll stop right away and very quickly, and then